Okay, hello and welcome. This is going to be a quick walkthrough of the first project for EE234. The first thing you're going to want to do is go to the Real Digital website and click on the resources link and download the proper board support file. The board support file is going to be, I've already downloaded it, but I'll just show you. It's this one here, the RevD for Vitus 2020. So download that and put it in a directory where you know where it's at, because we're going to need it here in a little bit. Then I'm going to go ahead and jump into the lab, and we'll take a look at the first requirement. Oh, it's a tutorial, that's right, going through installing the tools and setting up a first project. So I'll let you read through that. If you haven't installed the tools before, there's a little installation guide here, shows you some of the screenshots. And then we'll get down into creating a project and doing the work of the lab. So I've already started Vitus up. I'm just going to spin through this real quick. Let me move this window. And there's the Vitus window. I've already started it up. So this is what the Vitus IDE looks like when you first get in. This is just a welcome screen. You can use the wizard here and create stuff if you want, or just close it and start from scratch. I think that's what I told you to do in the lab. So the first thing we need to do is set up the Blackboard so that software can get to all of the resources on the board. So you're probably aware from 2.14, or hopefully from some previous experience, that the chip on the board, the Zinc chip, has both an FPGA inside of it and an ARM microprocessor. And in this class, we're going to use the ARM microprocessor. But we'll want to target a bunch of the hardware devices on the board, buttons and switches and LEDs and the like. So to make all that stuff available, and also to configure the ARM processor with the parameters that are on the circuit board, things like the clock frequency and things like the amount of memory that's on the board. And the ARM processor can't know about that unless we tell it. And the Vitus tool set can't know about it unless we tell it as well. So to do both things, to set up the ARM processor for use and to program the FPGA so you can get at all the onboard utilities, you can do that in one step. And that step is to import the design that we just downloaded, the zip file you just downloaded in the previous step. So I've already downloaded it, so I'm going to go navigate to where it is. I'm going to import the exported zip file, so the first link there. And I'm going to browse to where I put it, which is on my C drive, Xilinx projects, and Vitus. And I think I didn't put it there, so I'm going to go back up one. And I think I must have put it in this one. Yeah, I'm going to move it to here. There it is. So I'm going to select that one and click Finish. Now this is just loading the file into the tool, but I've got to apply everything that's in the file to the board. So after I've got this loaded here, I want to click on it, make sure it's blue, and then say Project, Build Project. And what that's going to do is go through the zip file and pull out the various parts, the various initialization files that are needed to set up the board correctly. There's a tickle script in there that sets all the clock frequencies for the processor and the amount of memory and the depth of the memory. There's an FPGA programming file that sets up the FPGA to map all of the buttons and switches through. There's a couple of other files too. There's the XSA file. That's the file that maps all the physical pin constraints. So which pins are connected to which devices, what their drive strengths are, all that kind of stuff. So this takes a few moments. There's a lot going on, but once you do this the first time, you can just reuse the same board setting for all the rest of the projects. So you don't have to do this every time, just once at the start of a project. And if you use the same project shell going forward, you don't have to ever do it again. So now once this process finishes, we're going to have to go ahead and apply these settings to a new application project. So the steps are configure the board with the information in the blackboard.bist project, and then set up a new project that is going to draw from that stuff when we write software. Okay, looks like that process is finished. So the next step is going to be, as mentioned, to create a file, a new application project. So this new application project is going to have the hardware we just built, but also software in it. So this brings up a little create new project guide. You can just click next through that. Here I want to make sure that I've selected this hardware configuration. The idea is you could have a whole bunch of different hardware configurations, and you've got to pick one to associate with your current project. Well, I want to pick the one we just used. In fact, I'll pick the same one for all the projects in this class. Click next and give it a name. I guess I'll call mine proj1. Not very inventive. Next. And the domain we're going to use, there's only one domain on this chip, so you can just click next here. And now it's getting some templates. We're going to use just an empty application. So I'm going to click on empty application, a blank C project, and hit finish. And that's going to bring up a couple of informational windows to tell me about my project. Okay, are you done? No, you're not done. Now we're done. So just some information. I'm going to close both of these. Don't really need to leave those open. You can if you want to. Click through them, read through them. Okay, now we have the blank IDE, and now we can add new files. So I'm going to go over here and click on source, make sure source is selected, and then if I right-click on it, I can add a new file. And this is going to add a new source file to my design. Now, to start the class, we're going to be writing in assembly language. Later on, we'll write in C, but for right now, we'll write in assembly language. So I need to choose a file name that ends in .S. And that suffix, the .S, that's how the tools know I want to write an assembly and use the assembler to process it. So I guess I'll call it proj1 again. Project1.s. Finish. And that's going to open up a blank editor window. So for this project, you can copy and paste the code that we gave you in the tutorial. So I'm going to do that now. Select, copy, paste. So just paste it in exactly as it is. So now the code is in the tool and ready to go. Before we can execute it, we're going to have to build this as well. So I'm going to make sure that I've got the source file selected and come over to Project, Build Project, and that's going to run the assembler and get it all set up to go. All right, doesn't take very long. Now I've got the hardware defined and I've got some software defined I want to execute. Now I can download it to the board and run the project. Before I can do that though, I've got one more step to do. I'm going to come here and choose a run configuration. The idea here is there's a whole bunch of different choices for debug and execution environments. I'm going to choose the GNU debug environment right here, Single Application Debug, GDB. Just double click on that and that'll open up the panel to configure the run. I'm just going to leave all the defaults set there. So I chose one, leave the defaults set, and come down here and hit run. And what that's going to do is transfer both the hardware definition and the software to the board. And now you can't really see this, but the board just finished programming. You saw that window pop up. And now I'm activating the slide switches, and every time I push a slide switch on my Blackboard up, the corresponding LED turns on. And that's really all there is for the first part of the project. Let me show you one other thing though before I go. If you want to, this will speed things up in the future. If you come down here to Run Configurations again, and this is the one we chose, the GDB. Right here under Target Setup, if I unselect Reset System and reprogram the FPGA and save that, that'll just make the tools run a little bit faster. You don't have to uncheck them. You can go ahead and reset and reprogram every time you download a new file, but it gets a little annoying later on. All right, so that's it for the first project. From here, you just modify some of this code. There's going to be a couple of other instructions you'll add in. I'd encourage you to play around a little bit, try different instructions, go look through the ARM manual perhaps. Feel free to click on any of these files over here to see if you can figure out what's going on. Like, for example, if I want to go into the platform, I can look in all these files here, and it'll tell me something about what's happening with the circuit board. I just double-clicked on the platform.spr, and I can look about in here to see what's going on. Here's some of the settings that the processing environment's going to use. You can't break anything. Just go ahead and look around a little bit and get familiar. Okay, that's it for now. See you in class. Bye.